Okay, so let's have a go at finding the greatest possible domain of a composite function. Here we have f of x equals x squared minus 4, where x is in R, and we have g of x equals root x plus 1, where x is bigger than or equal to minus 1. Let's start by expressing this using a mapping diagram. So g of f of x means we first apply f and then we apply g. So the values in this middle section here have to be in the domain of g. And we know the domain of g is x is bigger than or equal to minus 1. So we have to have values in here that are bigger than or equal to minus 1. And that means the outputs of f must also be bigger than or equal to minus 1. So what we need to do next is solve this inequality. Adding 4 to both sides gives us x squared is bigger than or equal to 3. And if x squared is bigger than 3, that must mean that either x is bigger than or equal to root 3, or x is less than or equal to minus root 3. Finally, we need to make sure we've answered the question by giving our answer in set notation. To put our answer in set notation, we use curly brackets and we use x colon before writing the inequality. We have a separate curly bracket for each region because there are two separate regions, and we join them together using a union symbol which stands for OR. So we have x is less than or equal to minus root 3, or x is bigger than or equal to root 3. Okay, here's one for you to try for yourself then. Pause the video, then come back and check your solution against mine. Welcome back, here's my solution then. This time we've got f of g of x, which is different to last time, it's the opposite way round. So this means we're going to apply g first, followed by f. Let's draw a mapping diagram to see what this looks like. And so this time, the middle section represents the domain of f. And that means we need values that are bigger than 2. So we need the outputs from g of x to be bigger than 2. Let's solve the resulting inequality. This quadratic factorises to give x plus 2 and x minus 5. And a quick sketch will show us the region we want. So the critical values from these brackets are minus 2 and 5. So if x is bigger than 0, we want the region above 5, below minus 2. So we get x is less than minus 2, or x is bigger than 5. Let's write that into set notation. We have x is less than minus 2, or x is bigger than 5.